Okay, 7.5, exterior angle measurements. We're going to discover the sum, keyword discover, of the exterior angles of a polygon. Students will be able to solve for unknown exterior angles. So let's talk about first, exterior angles. The exterior angle of a polygon is formed adjacent to each interior angle by extending one side of each vertex of the polygon. So if we look here, we come across, we start on this edge, we extend this side, then we have an exterior angle formed. If we come across this way, we extend the side, and we have an exterior angle formed here. Same thing all the way around. So these are all my exterior angles of this polygon, which is a six-sided shape, a hexagon. We look at a triangle right here, it's the same concept. We start right here and extend the line all the way through, and we have an exterior angle. So what we're trying to do today is tell you how to find the measure of each of those exterior angles if I add them up, the sum. If we look at this picture, each interior plus each exterior angle equals something that we already know. If we look here and we say this angle plus this angle, how am I going to know what that is? Well, we look and they lie on a straight line. Every one of these two angles right here are on a straight line. This one plus this one plus this one, this angle plus this angle, all add up to 180. Each of them add up to 180. So this one plus this one is 180 because they lie on a straight line. So every interior angle plus every exterior angle is going to add up to be 180. So if I'm given each interior angle, calculate the measure of the adjacent exterior angle. Well, this says the interior angle is 100. But just to kind of show you, I'm just going to draw a picture. So if I have a polygon, maybe something like this, kind of go around, and I say, well, this one right here is 100. What's the measure of this exterior angle? Remember, the exterior angle, if we start here and we keep extending that line, is going to be this side. So what would this plus this be? It's going to be 180 because they lie on a straight line. So the exterior angle is 80 degrees. Okay, on this one, interior angle measures 80. Well, without having to draw a picture this time, if it's a linear pair, that means that they both have to add up to be 180. So the exterior angle is going to be 100. Okay, we're going to talk about the sum of the exterior angles of any polygon. Last note, in 7.4, we talked about the sum of the interior angles. So today is a little bit different. It's the sum of the exterior angles. The sum of all of the exterior angles all the way around. So given the triangle to the right, answer the following. How many linear pairs are formed? Well, let's count them. So we start here. There's one linear pair. Okay, come right here. Here's another linear pair. So here's one, here's two, here's three. There's a linear pair right there. So there's three linear pairs formed. Okay, the next question says, what is the sum of the linear pairs? Well, each linear pair is 180 degrees. So if there's three of them, we have 180 times 3. So that's 540. What is the sum of all the interior angles of a triangle? We know this. The sum of the interior angles of a triangle is 180. We also discovered that yesterday when we talked about the interior measures of a polygon. So D says, what is the sum of the exterior angles? Well, I'm going to take this total sum of all the linear pairs and I'm going to subtract what the interior angles are. So that's going to give me the leftover, which is going to be the sum of the exterior angles. So I'm going to take 540 minus 180, and that gives me 360. So on a triangle, the sum of the exterior angles of a triangle is 360 degrees. All right, let's try it for a quadrilateral. Draw a quadrilateral, which is a four-sided polygon. Does not have to be a square, does not have to be anything specific. There's all kinds. There's trapezoids, kites, squares, rectangles, those are all four-sided polygons. We're going to extend each side to locate an exterior angle at each vertex. Okay, so let's just draw a four-sided figure here. Just so that it's not really perfect, we'll draw it kind of like this. The way we extend the lines, now this is something that was a little bit confusing, I think, for some of the students last year. Let's start at this vertex, and let's just go straight across this line, and then we just go dot, 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 and extend that. That's an exterior angle right there. This is the interior angle that makes the linear pair with it. So let's come along this line right here, and then keep extending it, dot, dot, dot. Then we're talking about this exterior angle. Let's do the same thing here. So now we start here, we go across, straight across, dot, 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 dot. This exterior angle. And then start right here at the same one we just ended on, straight across, dot, 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 dot. This exterior angle. So I'm trying to figure out if I add all four angles up of a polygon, a four-sided polygon, what is the sum going to be of the exterior angles? Hey, and your four-sided polygon might look a little bit different than mine, and that's okay. First of all, how many linear pairs are formed? Well, here's one. Those both lie on a straight line, so there's one. Here's another one right there, so there's two. Here's another one, so there's three. And here's one more, four. So on a four-sided polygon, I have four linear pairs that are formed. Okay, on a three-sided polygon, I had three linear pairs that are formed. Pay attention to the pattern here. So what is the sum of all the linear pairs? Well, that's just taking 180, because that's the sum of a linear pair by definition, times by 4, because I have 4 of them, so 720. Okay. What is the sum of all the interior angles? Well, this is what we worked on yesterday. Remember that we had, if we had 4 sides, I subtract 2 from the number of sides, so that would be 2, and I times it by 180. So that gives me 360. The formula, in case you can't remember, is 180 times the number of sides minus 2. That's what I used here. And I got 360. So we're going to use the same rationale that we used up on 1D, right up here, where we take the sum of all the linear pairs and we subtract the sum of the interior, and that's going to give me the sum of the exterior. So the sum of all the linear pairs was 720. The sum of the interior angles was 360. So I'm going to subtract that, and I get 360 degrees. Now that's the same as the triangle. The same on both. Do you think this is true for all figures? Let's check it out. Okay, so we're going to complete the table. We already know this one. Three-sided polygon is 3 linear pairs. A four-sided polygon is 4 linear pairs. And yes, there is a pattern. A 5-sided polygon is going to give me 5 linear pairs. And if you don't trust me on that, go ahead and draw it. A 6-sided polygon is going to give me 6 linear pairs. And a 15-sided polygon is going to give me 15 linear pairs. The sum of the measures of all the linear pairs is just 180 times each of these numbers. So go ahead and fill that in. Same time that I am. Get your calculator out. 3 times 180. Four times 180. 5 times 180. 6 times 180. And then we jump to 15 times 180. Okay, just to recap, right here on this line, we were taking the sum of all the linear pairs. So I took each of the sides and times it by 180, because that's the sum of all the linear pairs. The sum of the measures of the interior angles, that goes to yesterday. That was the formula 180 times the number of sides minus 2. That's how I find the interior angles. So remember, a triangle, three-sided, the sum of the interior angles ends up being 180. Turn the screen back on, sorry. Okay, a four-sided polygon, well that's 2 times 180, so that's 360. A five-sided polygon is 5 times 180, so that's, 3 times 180, so that's 540. A six-sided polygon would be 4 times 180. That's 720. And a 15-sided polygon is going to be what? 13 times 180. So 2340. The sum of the measures of the exterior, well this is when we have to take the sum of the linear pairs and I have to subtract the interior angles, and what's left over is going to be the exterior. So if we take 540 minus 180, we get 360. On this one I take 720 minus 360 and I'm going to get 360. On 5, 900 minus 540 is, can you guess? 360. 1080 subtract 720 is 360. 2700 minus 2340 is 360. So we just discovered that the sum of the measures of the exterior angles is always 360. Now let's try to see if we can use that knowledge to help us figure out some things about some shapes. Find the measure of each exterior angle of the regular polygon. Remember yesterday, the word regular means that all the sides and all the angles are the same. Okay, so if I want to find the measure of each exterior angle, okay, let me just draw that for you. So I start here and I go dot, 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 dot. Here's one angle. Here, dot, 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 dot. There. Go here, extend my line. Go here, extend my line. Here, and you should really practice this to make sure, don't just watch me do it, but make sure you know how to extend those lines properly to find the exterior angles. So I'm trying to say, what is each one of these measures? Now this only works when we have a regular polygon. I know the sum of the exterior is 360, and there's 1, 2, 3, 4, 5 angles, and they're all the same measure. So I can just take 360, divide it by 5 to find out what each one is. So 360 divided by 5 is 72. So each one of these angles, this one's 72, this one's 72, this one's 72, this is 72, and this is 72. Alright, let's try this one. This is an octagon. So we're going to start here, extend, boom, boom, boom. Extend my lines. Okay, and so I'm trying to find the sum of all of these angles first, and then what each one is. Well, the sum, now that we've proved up here that it's always 360, I don't have to go to a bunch of work. I just know the sum of all these angles on the exterior gives me 360 degrees. There's 8 sides, or 8 angles, so I'm going to divide by 8, and that tells me that each angle measure is 45 degrees. Okay, if a regular polygon has 100 sides, calculate the measure of each exterior angle. Well, that just means I'm going to take 360, and if there's 100 sides, there's also 100 exterior angles. So I divide it by 100, and I get 3.6 degrees. Try to visualize that in your head. A polygon with 100 sides, that's like barely even, changing all the way around here. It almost looks like a circle. So each exterior angle is going to be very small. 3.6 degrees. That makes sense in the context of the problem. Calculate the number of sides for each regular polygon given the following information. So the measure of each exterior angle is 30 degrees. So if each angle is 30 degrees, I'll just kind of draw a picture, rough sketch of something. Okay, each exterior angle measure is 30 degrees. How am I going to figure out how many sides? It's going to be the same thing as up top. If I divide 360 by 30, that's going to tell me how many sides there are. So 360 divided by 30, and I get 12. So this would have to be a 12-sided polygon. Remember, it's a regular polygon. Okay, if each exterior angle is 18, well then I'm just going to take 360 divided by 18, and I get 20. So the measure of each exterior angle is, the number of sides is 20 on that one. Okay, the measure of each interior angle is 156. Okay, so think about this. This is saying interior angle. I'm just going to draw a simple polygon here, but if this is 156 and it says what's the measure of each exterior angle, remember each exterior angle makes a linear pair with the interior angle. So it would be 180 minus 156. And that is 24. So every exterior angle would have to be 24. Okay, the measure of each interior angle is 162. So remember, it makes a linear pair. So I'm just going to take 180 minus 162, and I get 18. That's the measure of each exterior angle. So on these bottom two, we were using the information that the interior angle makes a linear pair with the exterior angle. And up here, we were just dividing the sum of the exterior angles by either the angle measure to get the sides, or we could divide it by the number of sides to get the angle measure. It works both directions on that one. So in summary, from yesterday, to find the sum of the interior angles, we take 180 and we multiply it by the number of sides minus 2. That gives me the sum of the interior angles. The sum of the exterior angles is always 360. I don't have to have a formula to find that. I just know that now. So if you have a regular polygon, then blank divided by blank will give you the measure of each exterior angle. Well, that's what we did above. Then 360 divided by this is kind of a small spot to write this, number of sides will give you the measure of each exterior angle. This also goes that if you divide it by the number or by the angle measure, it will give you the number of sides on that. That's it.